Okay, so last thing with these exponential functions, we do need to talk about exponential decay. So this is when your graph goes, I guess there's a whole spot in the notes. That's okay. It's when your graph goes down. That's how you know that it has decayed. This is what we want our COVID numbers to do because then it flattens the curve. You know that you have exponential decay when your b value is less than 1. So when you're looking at like your equations and stuff, that b value is less than 1. Today, again, you're going to see some story problems and you are going to have to find that b value. And you're, instead of like yesterday, or I'm sorry, on Friday, we did 1 plus the rate. Today, you're going to do 1 minus that rate. And don't forget that for that rate, you're going to have to take the decimal and change it, take the percent and change it to a decimal. So let's take a look at a couple of examples. So we have, these things are called pica, I guess. It says the number of pica in a region is decreasing. How does the decrease in the pica population for 5 years compare to the population for 10 years? So we've got to figure out 5 years and 10 years. But first thing we need to do is figure out what's the equation. So here's our pica. They look like a rat. So your equations are still going to be y equals a times b to the x. A still stands for the initial value, and it tells you right here that there's 144 of them. Now your b, because we are decreasing by 8% each year, so 8% first of all, there's the decimal, so move it 1, 2. So 8% is 0.08. Now for the b value, for b, you're going to have to do 1 minus 0.08. And if you take 1 and subtract 0.08, you get 0.92. So there's our equation. And we know that this is exponential decay because your b value is less than 1. So let's plug into Desmos here and figure out what it would be after 5 years. So we take 144, parentheses, 0.92, get out of the parentheses, and then raise that to the 5th power. So after 5 years, we are down to 94.9 pica. But let's delete that out. What do we have after 10 years? After 10 years, we're only at 62.6 pica. So that's how you plug into the exponential decay formula. So again, it's the same equation, except for that b value, you do 1 minus. So like for the try it down here, they said, well, how would the intervals be affected if it increased at a rate of 8%? So if it increased, our equation would be a little different. We still would have the 144, but the b value, if it's increasing at 8%, remember, if it's exponential growth, it would be 1 plus the rate, so 1 plus 0.08. So we would have 1.08 to the x, and then you would plug that in. So I'm not going to go over this example because we did enough of these, or you did these on Friday, but if you need a little bit of a review over the how to plug into exponential growth equations, check Fridays out. So again, major things for today, kept this one nice and short, is that for exponential decay, you are going to do 1 minus the rate, and they give you the rate all the time as a percent, and then you just have to make sure you move that decimal place and then plug it on in. So your assignment is short and sweet today. The next 3 days are virtual. Please make sure you are logging in each day. You will have something to complete each day.